Good day everyone. Today let's tackle about continuous distributions. So look to an introduction of continuous uniform distribution. For the uniform distribution, let f of x is constant over the possible value of x. So as you can see, we have our a here, the minimum value, and b, the maximum value, and a and b are any finite values. So any interval of equal lengths are equally likely to occur. So, but in uniform continuous distribution, it is simply a rectangle. So, our area here is equal to 1. So, our rectangle, or the formula of our rectangle is A equals base times height. Note that our base is here, which is B minus A, and our height is f of x. So, b minus a times f of x equal to 1. So to find the f of x, we have f of x equals 1 over b minus a. Let's see a little more formally. The probability density function of uniform distribution, we have f of x is equal to 1 over b minus a for x is equal or between a and b, or 0 elsewhere. Under this uniform distribution, we have a theorem. If x is uniformly distributed over E and B, then our expected value of x is equal to B plus A over 2. And our variance of x is equal to B minus A squared over 12. And our moment generating function, or MGF, is equal to E raised to the power of TB minus e raised to the power of ta all over b minus a times t. To prove the mean, we have the integral of x times f of x dx. We know that it is support from a to b, and our f of x is 1 over b minus a. So any value of lower limit and upper limit, which is our a and b. So we have the interval of x times 1 over b minus a dx evaluated from a to b. So for the constant rule, we have 1 over b minus a times integration of x dx evaluated from a to b. So to simplify, we have 1 over b minus a times x squared over 2 evaluated from a to b. So now we can evaluate it, and we have 1 over b minus a times b squared minus e squared over 2. And so we all know that b squared minus e squared is is a product of those squares squared. So we have 1 over b minus a times b minus a times b plus a over 2. So b minus a is cancelled out. So we have here the left expected value of x is equal to b minus a over 2. To get the variance of variable x is the second moment minus the first moment squared. We find first the second moment. So we have here the second moment is equal to integration of x squared, integral of x squared times f of x dx evaluated from a to b. Like for our expected value of x, we simplify it, and we have 1 over b minus a times the integration of x squared dx evaluated from a to b, and 1 over b minus a x cubed over 3 evaluated from a to b. And now we evaluated it, and we have 1 over b minus a times b cubed minus a cubed over 3. So we know that b cube minus a cube is the product of um, 2 squared. So we have 1 over b minus a. So times b minus a times b squared plus plus a squared all over 3. So we have now our expected, the second moment here is b squared plus eb plus a squared all over 3. So now we get the first moment squared. So our first moment squared is just simply b plus a over 2 squared. So because we all know that our first moment is b plus a over 2. So to get the variance, the x is equal to b squared plus eb plus a squared all over 3 minus b plus a minus 2 squared. And to simplify, we have b squared plus 2ab plus a squared all over 4. And so simplify again. And we come up with this 4b squared plus 4ab plus 4a squared minus 3b squared minus 6ab minus 3a squared all over 12. So cancel out the like terms. So we cancel out this and we come up with b squared minus 2ab plus x squared all over 12. So we have now our variance of x is equal to b minus a squared all over 12. Now we can get the last, which is the moment generating function. To prove, we have our MGF equals to expected value of e raised to the power of tx is equal to integral of e raised to the power of tx times 1 over b minus a dx evaluated from a to b. So like the constant rule, 1 over b minus a times the integral of a raised to the power of tx dx evaluated from a to b. So to integrate this, we have to let u equals tx. Since our x here, our t here is a constant, so we have our du is equal to t dx. To find the dx, we have du over t. So we come up this 1 over b minus a times to the power of tx over t evaluated from a to b. So we have 1 over b minus a times e raised to the power of tb minus e raised to the power of te all over t. So to simplify, we have our MGF or the moment generating function. We have e raised to the power of tb minus e raised to the power of ta all over b minus a times t.